Welcome to the third lesson, Continuous Management in DevOps. In this lesson, you will learn about continuous code management, version management, code organization, automated testing, continuous integration and delivery, code review, and documentation. So, let's get started. Continuous code management refers to the process of organizing, storing, and maintaining the source code of software projects. Effective code management is critical for ensuring that code is reliable, secure, and easy to maintain. Here are some key principles of code management. Version control is essential and a central principle for code management. It enables developers to track changes to the code, maintain a history of the changes, and collaborate effectively with others. Version control systems like Git, Mercurial, and SVN are commonly used in software development. All other principles of code management are dependent on the existence and adoption of version control in the development or engineering. Organizing code in a structured and consistent manner makes it easier to read, understand, and maintain. This includes using meaningful variable names, functions, and comments, as well as following established coding conventions. Automated testing is crucial for ensuring the reliability and quality of code. Developers should write unit tests, integration tests, and end-to-end tests, and automate them as much as possible to catch errors early in the development process. We will be covering the automated testing in detail when we discuss the test stage of the DevOps life. Continuous integration, CI, and continuous delivery, CD, are practices that help teams deliver code faster and more reliably. With CI, developers merge their code changes into a shared repository frequently, and automated tests are run to detect issues. CD automates the deployment of code changes to production systems. We will be covering the SICT in detail when we discuss the build. Code reviews are an important part of code management. They help ensure that code is maintainable, secure, and follows best practices. Code reviews also provide an opportunity for knowledge sharing and mentoring. In this, peer developers review the developed code and provide their review comments. Documentation is essential for maintaining and supporting software projects. Developers should document the purpose and usage of functions, classes, and modules, as well as any configuration settings or external dependencies. These principles become essential for implementing the stage 2 of the DevOps life. Version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. It allows developers to track changes, collaborate on code, and undo mistakes. There are two types of version control systems. First is centralized version control, a central repository that all team members work from. Second is distributed version control, a set of multiple repositories that can be worked on independently. Now the question is which version control system we should choose from the two options available. As per the Acumen research and consulting data, centralized version control still leads over distributed version control in the market share. While centralized version control, CVC, is a type of version control system in which there is a central repository that contains all versions of a project's source code. CVC systems are typically used by software development teams to collaborate on code and manage version history. CVC systems like Subversion, SVN, are best suited for medium to large-sized teams working on complex projects that require tight control over source code changes and versioning. They are also useful in situations where teams are geographically dispersed and need to be able to access the central repository remotely. CVC can also be useful for organizations that need to maintain tight control over their source code and ensure that changes are properly reviewed and approved before being merged into the main codebase. Additionally, CVC can be useful for organizations that need to maintain a detailed audit trail of all changes made to their source code. The distributed version control, DVC, is a type of version control system in which each developer maintains their own copy of the entire project repository, including its complete history. DVC systems like Git are widely used in software development because they offer several benefits over centralized version control systems. DVC is best suited for software development teams of any size, including solo developers who are working on complex projects that require high levels of collaboration and flexibility. DVC allows developers to work independently, and this means that multiple developers can work on the same project simultaneously without the need for a centralized server, making it easier to collaborate on large and complex codebases. DVC is also useful in situations where developers need to work offline or with limited network connectivity, as each developer has a complete copy of the project's history and can work independently without needing to be connected to a central server. Additionally, DVC is often used in open-source software development, where contributions can come from many contributors who may not have access to a central server or have different workflows and preferences for managing their own code. Hope this helps you in deciding which one would suit your benefits of version control are. It helps to easily revert to a previous version of your code by maintaining history and supporting recovery of the code. It facilitates collaboration between multiple developers so that they can work on the same project simultaneously. Due to the support for traceability, it can help track changes made by different users and see who made which changes. Branching and merging makes experimenting with new features without affecting the main code base. Using version control involves the following process cycle: initializing a repository, which requires creating a repository for your code. Committing changes, it is about saving changes to your code and creating a new version. Branching and merging, creating a new branch to experiment with changes and merging it back into the main code base. Collaboration, that is working with other developers and resolving. Finally, let us learn some of the best practices of using the code management system. To start with, use descriptive commit messages. Keep commits small and focused. Regularly push changes to a remote repository. Use branching and merging to manage changes. And, if you are using JIT, then use a JIT ignore file to exclude unnecessary files from the repository. Lastly, using modern version control system provides elaborate code review features. It is because the code review system is a very important part of the code management to ensure good quality code resides in your production environment. To facilitate that and make the code review exercise effective, the following are some best practices for code review. Establish clear guidelines. Before starting code review, it is important to establish clear guidelines on what should be reviewed, how it should be reviewed, and who should be involved. This helps to ensure that all team members are on the same page and understand the expectations. Review small changes frequently. It is easier to review small changes frequently than it is to review a large amount of code all at once. Reviewing small changes frequently also helps to catch issues early on and avoid problems down the line. Be constructive. Code review is not about finding fault in someone's work. Instead, it is an opportunity to provide constructive feedback that helps improve the quality of the code. Be respectful, polite, and focused. Use tools to aid review. Code review tools can help to automate the process and make it more efficient. Tools like GitLab, GitHub, or Bitbucket can track changes, allow reviewers to add comments, and help keep track of revisions. Check for code quality. Code review is an opportunity to ensure that the code meets the project's standards, such as readability, maintainability, and performance. Check for code smells, inconsistencies, and compliance with best practices. And last but not the least is following up on feedback. After the code review, it's important to follow up on the feedback provided. Address any issues raised and ensure that the changes are incorporated into the code. This helps to maintain code quality and ensures that the code review process is effective. By following these best practices, teams can ensure that their code review process is efficient, effective, and contributes to the. You have successfully completed Lesson 3 of the DevOps course. In the upcoming lessons, we will deep dive into the remaining 6 stages of the DevOps lifecycle.